In this video, we're going to talk a little bit about radar and plotting radar data using Python. Now, this is not a formal part of the weather technology course, but radar is really cool and we can really gain a lot of information from interpreting radar. And so I encourage you to first view Adam's videos on kind of the background about radar and how they work a little bit, and then come back to this video so we can see how we can plot this radar data. Now, we're not going to be able to use some of our common declarative syntax things, as we cannot yet read it and plot our radar data in that format. However, we can use Python in general and use it in a bit more of its gory detail to get to the same objective. And so there is a new plotting_NEXRAD_radar notebook. Go ahead and duplicate that file and put it in your working notebook. I have already done so. And so I renamed it radar_plotting here, which I opened up and then have before you. Don't forget to change your Python kernel to be Valpo Spring 2020. And then what we see here are 4 or 5 different cells that are going to contain the different necessary bits of code in order to accomplish the making of our radar data. Now, our radar data actually comes from Threads server, as we've been using for the most part this semester. And so here's our Threads top-level catalog. Specifically, we're looking at our radar data and accessing our level 2 radar data. There are differences between level 2 and level 3 radar data. Level 3 radar data are a bit more post-processed, but I find it just a little bit easier to access and work with the level 2 radar data. So that's what we're going to demonstrate here today. And when we click on this link, we see that there are a whole bunch of different NEXRAD radars, which are located all over the world, but primarily within U.S. territories or the United States in and of themselves. And so these are in roughly reverse alphabetical order. And so we're going to plot some radar data for near Valpo, which our closest radar data location is Chicago, which that 4-letter identifier is KLOT. So let's go ahead and click on KLOT. And you can see that we have about a month's worth of radar data available from this resource. So unfortunately, data older than March 18th, we just don't have data for in this format. There are other ways to go about obtaining that data, but that go beyond the scope of both this video and this course. And so if we click through just on one of these dates, say April 17th, we can see that we have a lot of different data files that are available from this particular day. Our file name formats are pretty standard. Level 2 underscore, then the name, the station name, underscore, the year, month, day, underscore, and then the hour and minute. But one thing that you're going to notice about the hour and minute is we do not have a repeating cycle, unlike satellite data that has a much better repeating cycle here. And so we're going to need some help to be able to read in this data. But let's go ahead and just click through on one of these for a second so we can see. Looks just like our other data sources. And specifically, we're going to be trying to generate this OpenDAP link, which if we link through here, we see the full gory link for this particular site. But now let's go back to our script here. You can see that we have to bring in a whole bunch of different Python modules in order to make this happen. And so we don't need to worry about all the details going on here, but that these are all the different pieces that are necessary to make our final image. This next cell contains a definition or a function that allows us to then parse through all those different files with those different times to find the one that is most appropriate or closest to the time that we desire. Note that if you put in something that is in the future, it's not going to be able to find, it is potentially not able to find a file. So you may receive an error, and if that is the case, just go back by an hour or so, or a couple of minutes, depending on what time it is. No need to worry about the details of what's going on here. It's just code to accomplish the task of finding our most relevant radar file for the time that we desire. In this next cell, this is where we're actually going to go ahead and access our data. And so I am using the date function to get the computer time from now. And so I happen to be recording this on Friday at about 10:40 in the morning. And so this is going to allow me to grab the current time and find the closest data file to the current time. Now, I said I had about 2 weeks or a week's worth of data, such that instead of using this second line, we could comment it out and use this first line and hard code a date in with time and minute here to gain access to that file. And I'll demonstrate that a little bit later in this video. Next, we're selecting which station we're going to choose from, and then we're going to use both our date variable and our station variable to help construct the string to get to our catalog URL. And so from there, then we're going to grab our catalog URL. Then we're going to use our function down here, this get_radar_file_URL, feed it our dataset file names with the date to then choose the most appropriate file and give us back that URL that we desire, and then ultimately open it up with our favorite friend, NEXRAD. Now note, I'm using some extra keyword arguments here to read this incorrectly. No need to know what really is going on here, but this is minimizing some prep work that NEXRAD would otherwise normally do, so we're turning some things off to make it a better experience for us. So let's go ahead and run this file, and hopefully we'll get a current data file, and so we see that it ran and it did finish. So we now do have access to a data file. We don't know exactly which time yet, but it is now saved in our object variable here, ds. From there, we need to start pulling data from this data set, and so we want to pull the station name, we want to pull the station lat and lon, and elevation, and grab our time from when our radar scan began, and then set that as our valid time. Because our data is coming across in polar coordinates, so for anybody who's currently in Calc 3 or will take Calc 3, polar coordinates is a thing, and in order to plot this, we actually want to get our lat-lon data to plot it with a map. And so we're going to need to use some projection information, so I'm setting up a stereographic projection here based on our station latitude and station longitude. And then I'm going to compute and convert from our range and azimuth from those polar coordinates to get some XY values, and then convert them into lat-lon coordinates for plotting purposes. And so we're just doing a lot of data manipulation here. But one of the key lines here is we're pulling out our reflectivity variable here. And so we see I'm setting that equal to a variable called ref, which is short for reflectivity. And the particular one we are reading in is reflectivity_hi. So let's go ahead and run that. It takes just a bit of time to run to be able to convert our x and y values into our longitude and latitude coordinates respectively. Then we want to go ahead and plot it up. Plotting it up actually doesn't take all that much code, but we've got to use the raw matplotlib to do so. And so we're just setting up a single image here with a fig size 10:9, and then creating our projection to be a plate Curie projection. And then plotting our image here using p-color mesh. We could also have used imshow, would work also in this situation. And then adding a color bar to our map using a reflectivity color scale here. We're going to add some counties and some states in order to have some geographic reference in our map, and then plot some titles on it as well using our reflectivity name and our station name and our valid time. And so if we go ahead and run that, we see we get we're downloading some of those county files there, and so the first time you run this, you'll have those messages just saying it's downloaded something. And you can see that around 10:30 was the time file that we got, 15:30 UTC, was when there was a snow band moving through the Chicago metro region, and it was actually still snowing here just a little bit in the greater Valpo area. But again, we're not relegated by just looking at whatever the current data is, which we see some pretty good snow falling here. But we could plot some data from, say, the thunderstorms that happened a while ago. So let's scroll back up here and let's comment out getting the current time, and let's put in a different time. And so let's put in April 8th, around 22 UTC, and we'll do 22:15. We'll see if there's anything on our radar from April the 8th at 22:15 UTC. There we've grabbed our data. We're going to make sure we get the most valid information for that particular time to set up our x, y, and long lat coordinates. And then plot up our data. And sure enough, this is when some thunderstorms were rolling through the area, and so we can see these wonderful thunderstorms going on here. Let's go ahead and go just a little bit in the future and see if we can get some storms more near Valpo. And so let's try 2315 UTC. And I'm running my 3 cells quickly in sequence here to pull in the necessary data and then plot it up. It's taking a little bit of time to run. The thread server may not be super happy with us right now. Probably got a number of files to parse through here. There, it took just a little bit of time, but now we got it to go. And we got some thunderstorms that were moving through kind of the whole geographic area here. We can focus in a little bit, actually, so we don't have quite such a wide angle view here as we are seeing for the whole of K-lot. And the way we do that is by this set extent area. And so we're setting it with longitudes, so from -91 to -85 longitude, and latitudes from 40 to 43. And so we can narrow this down a bit. And so we can say maybe from 88 to 86, and say from 42 to 43. Let's see what that looks like. We definitely zoomed in, but we're a little farther north than what I desired, so we need to come back just a little bit south. So let's go 41 to 42. And again, it just takes a little time to run each time. And there we go. We get a more focused area over just the Valparaiso area, for example. But maybe we went a little too far into the future, so let's go back a little time. So let's go to 22, maybe 45 UTC and see what it looked like then. So first we're going to run and grab our data, then we're going to process our data, and then we are going to plot our data. So we see there just a little bit different of what it looked like on April the 8th, when some of the rain and stuff was coming through the greater Valpo area. So that's it for plotting radar data. Pretty straightforward. There are other types of fields that are available from our radar. What we've been looking at here is primarily the reflectivity, but there is also velocity, correlation coefficient, differential reflectivity, and even one or two more. And those variables are available, and we'd plot them maybe slightly differently with different color schemes depending on what we were plotting. And all of that would just be baked into the different values we have here. And we can even list out all those variables. I'm going to go ahead and just list them so that we just get our names. And so, for example, we have reflectivity, HI, radial velocity, HI, differential reflectivity, spectrum width, correlation coefficient, and that's it. And so you see with each one of these, you'd have to change your various values to be associated with each variable. So these R_HIs would be with reflectivity. The radial velocity _HI would then be VHI. Differential reflectivity would be D_HI. And you just have to change all of those as necessary. Feel free to play around with this because it's a fun thing to do. But otherwise, that's it for making radar plots using Python. Thanks for watching.